So as computer programmers, we observed that there is a core central anomaly fundamental to our industry and our craft that is as follows: that the role of a developer is to model the world of the user, and in doing so, create software. And the role of the user is to interact within that model. This is what they call the developer-user divide. We as developers, we possess this core capability to, using computers, create models of the universe and embody logic in code. And then users use our applications. You've probably seen this a million times in every time you fill out a web form, what you're doing is you're creating data. And every time you browse a categorization system, you are browsing, you're interacting with categories. However, somebody has to create those categories, and somebody has to create those forms, and those things are not done typically by end users. They're done by us with our special power, our special skill. And this divide is contributing to, I believe, a profound bottleneck in innovation of our planet. Namely that, number one, the power of computing and programming and all this incredible stuff we've built in the last 40 years plus or minus has been done by programmers, not by people like my grandma and your grandma. And then the other part is that as programmers, we create the programs, but we are not there every step of the way in a changing world. The world is not static, so when the program is created, it is created statically, and then more changes to that program have to be made by more programmers. And we all know, evolutionarily speaking, that organism survival is not its strength, but its ability to adapt to change. And we as a species, in embracing computer technology, have arguably inhibited profoundly our capacity to adapt to change. And so because of this, it's an opportunity, it's a wonderful opportunity for, for things to be better.
The observation that comes to my mind in talking about the relationship between clients who request software and are the users of software and programmers who create them is that there's a bottleneck there, and that's the programmer.
Right.
The programmer actually represents a bottleneck between the user and interacting with or experiencing their data.
Like, it's like the Pope. The Pope is the intercessor to God, right? And you only speak to the Pope, and he speaks to God in Latin, of course. And so Python is Latin.
And we all know, as human beings too, that every time you hop from human head to human head with a piece of information, something's lost along the way. The age-old game of telephone.
Yep.
So for the programmer to properly embody the problem that the client wants solved in the software, they have to have a pretty vast understanding of the problem space. Many times they won't. There are lots of either very specifically edit this.
No edits.
Yes, edits.
First take.
Yeah. Some problems either require very specific technical skill to understand.
Yeah.
And if you lack that, you'll model it incorrectly. So we should get out of the way.
Right. The domain expertise is in the client, or we're consulting, we consult, so we have a client. But the domain expertise is in the person who's trying to use the tool, not the person who is creating the tool for someone else. So, the flying car. The best, the coolest analogy is like in the future we'll have flying cars. Well, we have flying cars and they're called airplanes, right? What is the difference between a flying car and an airplane? The difference is
it's the user interface, the user experience.
One is end user facing. It's the thing about a car is that anybody can drive one, basically. The plane requires, like you were saying, the 747 gives you this incredible power. And to be clear, so we're trying to empower end users to do what programmers do right now. Ideally, generally, however, there is not, I don't believe that that's totally possible. There's like an amount of skills that you learn in computer science school, for example, that are, that you're not learning a special language like in intro to programming. They just pick a language. How about Java? Sounds great, sure. And then they dive into data structures and algorithms and sorting and this and that. And so there's still a profound role for the skill of programming. And what we're trying to do is give end users both a tool and a skill. The tool is embodied through a piece of software, and that tool is designed to help people code, but the skill must come with the tool. You can't use the tool without the skill, or very well. You'll be able to use the tool better with the skill. Anybody can swing a hammer and hit things successfully, probably very hard, but building a house is a different story.
So why can't the average person, or why doesn't the average person program right now? Why do they not approach this skill?
Yeah.
When there's, if the observation that we're making is that programmers have this unique ability to map the relationships in the world, formally in a machine, right?
Yep.
And that gives them this power in the world. Why haven't more people gravitated? Why is there more of a for example, we have like computational neurology or whatever.
Right.
Like we have these we've had computing moving into different domains, but what is the barrier to entry there?
It's interesting. It's that idea, the idea of end user programming at all used to be a revolutionary concept. That computers were not even for people at all. They were only for these professionals that worked in the big offices and had the big giant computing. And then Jobs and Gates and a bunch of other people came along and championed this idea of personal computing, that a person could use a computer. And that was a radical, revolutionary idea at the time. And yet the shift proved that giving end users that power could, in fact, be valuable, and users were smart enough to use a computer that was designed in a particular way.
And it's interesting to point out there that there was just as much skepticism within companies like IBM, for example, about the idea of an average person having any use whatsoever for a computer in their everyday life. But once the argument for people having that power in the world was made by a compelling, company in Cupertino, for example, now we can't imagine our lives without it. And so the definition of a person's life actually changed because of having this new power.
Yeah.
And so having the ability to, rather than just use software, but create relationships in software with components that developers say create, would be an extension of that power, make it even more powerful.
It's like Jobs' original vision was to empower the end user. And when they first got computers in the hands of end users, that was the first thing they took on, is this programming space. And it was a major part of their vision, and kind of over the years, they couldn't figure out how to make money on HyperCard, basically, and ended up tanking the project, and they focused more on the hardware and the OS and all that stuff. But end user programming never really, HyperCard was huge, but it never really, I don't know what happened.
I think Myst was written in it.
Was it?
The game Myst, the first version, was a HyperCard app, I think. I think it was.
I know they tanked it. And there are examples of end user programming around the world. Probably spreadsheets being the best example, where people do incredible things with spreadsheets. My friend who works over at the Department of Health and Welfare, and Oracle was coming in to put in some $900,000 system for them, and he was like, I can do this all on spreadsheets. I can do it all on spreadsheets, and proved it. Just did it over a weekend. This huge, expensive system, He just busted it out in spreadsheets. Now, granted, it doesn't have, all these different things that a robust program would, but the functionality was made possible just using this simple tool called spreadsheets and a power user. He's not formally trained in programming at all, but he has the capacity to understand the basic abstractions of, branching and formula composition and functional composition, and did it, which proves that, like many, many, many industries, the specialized skill in computer science is not, in fact, the core of what we're doing. It's the core of what we're doing wrapped in all these layers of inaccessibility and obfuscation that not only must you understand logic, you must also understand the syntax of if statements and all this other stuff, right?
And how many programmers, no matter how many decades they've been in the industry, won't forget a semicolon,
right,
or forget which language they're programming in, or the little gotchas that can get you.
Syntax problems, and then just that's once you're editing Python. But just to get to the point where you set it all up so that you're editing Python and know how to run a code is a whole other bunch of things that you have to learn. So the learning code, getting into programming, learning curve is very, very easy.
So if I look at my own career, there was a point where, after I'd been doing it for a while, I started to see sort of abstract shapes in my head that represented what the code was doing. And then once I had that internalization of what the code was doing, that I could reason about programming in a better way.
Yeah.
And then it actually started to make intuitive sense. And it didn't make intuitive sense until I had that internal model. And so that may be the thing that, one of the things that's very difficult for someone approaching programming is that there isn't a visual component. There isn't something that physically manifests the structure of a program, the structure of data. What is it? We have an innate understanding of objects in space. We live in space. We're at home in space, but
physical logic.
Yeah, but there isn't a physical realm for computing.
Yeah. So we want to make programming easy. We want to make it as accessible as it can be, as simple as it can be, and no simpler. Which is to say, we expose the core abstractions of computing in a way that is analogous with the physical world. So another aspect of this is what we've called visual computing or physical computing or mechanical computing. Like they used to make computers out of pieces of they were mechanical, they were machines. The first adding machine, right? And there is a deep logic in the physical world.
As creatures that come out of the physical world, we have an innate understanding of things that are in our environment.
Exactly.
Heidegger said that I think it was that the world is disclosed to us, meaning that it's something that we, as things in the world, things that grew out of the world, things that we are at home in the world. There's familiarity, or what is it? I think familiarity was one of the terms that he used. That objects, that being, has a familiarity to us, that our minds somehow innately understand being and action that can be taken on physical objects. It's built into the hardware,
right,
so to speak.
And that, this is the thing about computer science, is that unlike many industries, the core skill of what computer scientists do is something that humans are doing already every single day. Classification and distinction, for example. So we'll get to it later, but the database, its core mechanism is classification and distinction. And we say this is a bottle. And in the database we would say this is a bottle table. Well, we would say there is a bottle table and this bottle is in it. So classification, everything about these objects is all the same. All bottles are the same. And then distinction is all bottles are different. So that basic mechanism of sameness but differentness, sameness and differentness, is I would say the core mechanism of how we make sense of the world. We embody what is based on this set of categories in our head that the first time we encounter something, we make a category for it. As children, we come into the world and we look around and we see all this stuff, and then these categories and distinctions start emerging. Oh, that thing is like the last chair that I saw. That's like the last lamp that I saw. They have the same function. They're the same. That chair is the same as this other chair, but it's different. It's also different. And so, Boolean logic. If this happens, then this also will happen. If I punch Mike in the face, then it's going to hurt. And so, that's what we're expressing in code is these things. And so we go into an industry and take all the stuff that they're doing, the knowledge that's in their head innately, and we manifest it in code. And so why are we doing that? It doesn't make any sense when they can do it themselves. When they are doing it themselves. We're just better at it. The thing about programming is that it is a very precise way of thinking. And what we're being trained to do, arguably, in school is to think in a very rigorous way. That's why having a conversation with computer programmers is sometimes very different than other people, because we are trained to have precision in our thought. We think very precisely. And so it's just a matter of taking someone and teaching them how to express their thoughts, or giving them an interface to express their thoughts in this precise way. And the clarity of their thinking will be equal to the clarity of their code, which is a beautiful, beautiful situation to have.
So, kind of feel around for a goal here.
Yeah.
Is putting a user interface on data and programming itself such that the user can very, very expressively paint their picture of the world and share it with others. Relate it to other pictures of the world. Say that this picture and that picture are the same picture, or they're different. They're different. And this, design goals would be that you can't say internally inconsistent things. A very interesting thing about that is that databases love representing that kind of logic. But this has a reference to that. You only have one of these if there's a that to point at it. You don't have orders without a customer that place the order. You kill the customer, all the orders go away. Using that rigor in the database seems to be a way of only letting people paint pictures of the world that are consistent. Right?
Consistent with the rules that they themselves
set up. Consistent with their own view, right? Which is an interesting aspect of it.
Yeah. Yeah. So the big question is why? Why are we doing this? To me, it speaks to the empowering end users to program a computer gives them the power to manage complexity in the world, to make sense of the world around us, to feel prepared for any situation in a way, and have a tool for making sense of what we encounter. And that power to manage complexity gives us the power to organize ourselves as individuals, the world around us, and collaborate with each other in groups in ways that are superior to our current ways. Our current tools are language, which is unstructured. It transmits thought as a stream of words, which we internally convert into mental structures, where data is structured data innately. And that translation layer where we take, Mike says something to me and I convert it into structure, is an extremely ambiguous one. This is called a misunderstanding. And without taking every word that Mike says and looking it up in the dictionary and saying, okay, Mike, did you mean pithy talking about the fibrous wood material, or were you referring to the concise statement that I made? Without doing that, we really have a very difficult time understanding each other at all. And so end-user programming is about precise thinking, communicating precisely, collaborating and organizing in a way that if we're going to save this planet from destruction, we've got to be able to work together better than we are right now. We've got to be able to collaborate and recognize our commonality and fight for common goals. We have incredible power in the world as a group united. And when we're all divided, we feel incredibly isolated and alone. And I personally feel that way quite a bit. And would love to be part of a cause. So there's a lot to do, and I think that this tool could help.
Yeah, I think a thought that came to mind as far as causes, for example, you've got there are many, many problems, economic or environmental. They have tons and tons of data that's produced all the time. But wouldn't it be nice, for example, if this or that climate model was something that someone actually set up, a physical model of the data, and said, here's something everyone can come and play with. And if we move carbon to here, here's what happens over time. Move it to here, here's what happens over time. Or this or that economic or tax policy. If we could actually see visually, I'm not just proposing, here's what the tax policy should be. Here are all the variables that are disclosed to all of us. Right. And if we change this to this, we see the change. And getting people to, in one way, it gets people to communicate using these models. Say, I create a model for my view of the world, but I'm not just doing that for the hell of it. I'm saying, here's my model of the world as I see it. Here, I'll give it to you, let you interact with it. And you can play with it and find out all the implications of my model of the world, right? I'm not giving you my argument for this. I'm saying, here's a model that I've created of this aspect of the world, giving it to you, and letting you and the rest of the world reason about it.
Yeah, like it reminds me of our recent political discourse and my feeling when watching it, that it's just two people talking past each other. There's not a real rigorous engagement that's like, oh, you see it this way and I see it this way on this specific point. These giant concepts flying by that, our country is so divided right now. And I believe that if we could communicate better, we would actually find that in tons of areas, like the reds and the blues, have a lot in common. And what we have in common is a lot greater than where we disagree. And if we could figure out what we do in fact agree on and just collaborate on that stuff, we'd have plenty to work with for the next millennium.
Yeah.
in terms of like ways to improve things.
I think that definitely, it's interesting how many different ways you can say the same thing and how many ways you can argue while agreeing with the person you're speaking with. Right. So I guess what would be interesting to talk about is so how would we do such a thing?
Yeah. Yeah, well, so we can talk some shop. Widgets framework.